How do we draw ray diagrams for curved mirrors? Why do we want to draw ray diagrams? Well, when you look in a mirror, you see an image. So the ray diagram can help you figure out where that image is going to look like it is. They sort of show you how the light travels when it hits the mirror. So we've got a curved mirror here. Let's just talk a little bit about how mirrors work. So a mirror has a focal point. So this is the point where light that's coming in parallel to this axis will focus. So what I mean by that is that light rays coming in parallel will bounce off the mirror and go through the focus. So will other parallel light rays. Draw them in here, and this one will go here. And we can see this by looking at the normal to the surface at the point where each light ray hits, and looking at the angle of incidence and reflection. And we see that they're the same, or at least as close as I can draw. Light that does not come in parallel to this axis won't go through the focal point, but it will converge at another point. Let's draw some rays up here. Draw rays coming in parallel like this. Okay. So let's look at those angles of incidence and reflection. Right. Got a big one here, and a slightly smaller one there. So I'm going to have something like this and this. Okay. So they will converge too, but they'll converge at a different point, but the point is in the focal plane. Okay. So parallel light rays will converge in the focal plane. And this is how you form images, right? From this part of the object, your light rays converge here, so you see that part of the object, the top of the object. From this part, the light rays from another part of the object converge here. So let's look at an actual object and draw a ray diagram. Here's our principal axis. And here's our focus. And let's draw an object. Just an arrow. Right? An arrow is really simple. So if we know where the head of the arrow looks like it is, where the image of the head of the arrow is, it's easy to draw the rest of the arrow. We know the bottom of the arrow is, wherever the bottom of the arrow is, it's going to look like it's just in the middle on our axis here, right? So if we think about the light coming from the head of the arrow, it's light, so it goes in all directions. It makes rays in all directions, like this. Right? We don't need to draw all those rays. Let's just draw a few of them. Let's draw some important ones. Let's draw one that goes straight from the head of the arrow to the mirror. Well, it's a convex mirror, or concave mirror, it's caved in. So we know that the light will then go through the focal point. We just saw that's how concave mirrors work. Let's draw a ray that comes from the head of the arrow and goes straight through the focal point. This is like the reverse situation. So light will come out parallel. Right? So this is just as we reverse the situation where a parallel light ray coming in would go this way. So the opposite's true if the light ray is coming in through the focus. And then another one we can draw is, let's draw something just as a check from the head of the arrow to the very center of the mirror. Right? So we know that the angle of incidence and reflection should be the same, so it will leave in exactly the same direction and go through that same point. Right? So the light rays from the head of the arrow are going to hit this mirror and then all converge here. So that's where the image will appear to be in focus. So the head of the arrow is going to be there. And we could do a similar kind of thing for each part of the arrow, and we would see that it's going to look like this. So when you hold up this arrow in front of your concave mirror, the image of the arrow is going to look like it's sitting right there.